Another edition of RCE. Again, this is Brock Palen. You can find us online at rce-cast.com. You can find the entire back catalog, link to all of our Twitters and our blogs and all that sort of thing. Once again, I have Jeff Squyres of Cisco Systems and one of the authors of OpenMPI. Jeff, thanks again for helping out.
Hey, Brock. And it's that time of year again. It's coming up on supercomputing.
Yeah, so once again, both Jeff and I will be at Supercomputing. We both have booths, both Cisco and the University of Michigan. Jeff, I understand your booth is way off into boonies, though.
Oh, yeah, we have a fairly terrible location this year due to an accounting mistake on our part. So admittedly our mistake, but please come find us. We're kind of in the back. I'll be hanging around my booth. I'll also be doing the normal OpenMPI State of the Union BOF. And also involved with a libfabric tutorial on Sunday. So be sure to sign up for that, too.
So we actually share our booth. We split it every year with Michigan State University, and we're recording this one day before the U of M Michigan State football game, which is kind of like one of the mini rivalries around here. So this is always kind of fun.
Yes, I think I will stay completely neutral and not make any comments whatsoever.
Well, I'm heading to Lansing this weekend, so we'll see how that goes.
All right, well, what do we got today?
So today we are going to be talking about a software project called Spack. So we have one of the developers with us. So Todd, why don't you go ahead and introduce yourself?
I'm Todd Gamblin, and I'm a computer scientist at Lawrence Livermore National Lab in the Center for Applied Scientific Computing. And I guess I'm also the author of Spack. And my day job is performance analysis research, and I've recently been getting into build systems or package management systems, mostly out of anger.
I can appreciate that as someone who did application support. So quickly, what is Spack?
So I guess we build Spack as a package management system, but I guess you could also call it a port system. It's basically a build from source package manager. And it was designed to deal with all the combinatorial issues that you face with software in HPC. So essentially, on a regular machine, in your Linux box maybe, you have a package manager. You install something, it installs the latest version of that, and you're done. On an HPC machine, you might want to install different versions of that thing compiled with different compilers and different compiler versions, and so the space quickly blows up.
So just before we go too much deeper here, I'm just kind of curious, where did the name Spack come from? It's kind of a fun name, but a lot of things come up for it when you Google for it. Where'd you get Spack from?
It's the supercomputing package manager. That's where we got it. We have since learned that there are other meanings for the word.
Oh, okay. Well, we will leave those off of this podcast here. For us, the only definition is the supercomputing package manager. That's cool. So, all right. Now, with that white elephant out of here, let's talk about what Spack is itself. So you say it's a build from source package manager. Why another build system? Why not port something like ports, or why isn't Yum enough and things like that?
So, I mean, we did look at BSD ports. BSD ports is essentially like a directory tree full of makefiles, as far as I can tell. And I guess we didn't really think that was the interface that people were used to using. I think the real inspiration for Spack, is my experience installing packages on my Mac, because that's a system that comes from the vendor without a package manager, and people want to install other software on it, and so they use things like Homebrew or MacPorts or Fink to install things on it. So, I mean, I think if you look at Spack packages, they look an awful lot like Homebrew packages. They're just in a different language.
Now, you mentioned also at the beginning, too, that part of the rationale for doing this was because was out of anger, I believe was the phrase. And both Brock and I were nodding like, oh, yes, I know exactly what you mean. Can you tell us exactly what you mean? Can you cite some examples?
So have you ever tried to build the Rose compiler?
I have not.
You have not? Have you tried? Well, I mean, the last time you installed something on an HPC machine, did you find all the dependencies that you needed? Because when the software that we use is becoming a lot more complex, and so when we try to go build things on the supercomputer, I end up having to go down the rabbit hole of installing the software and its 10 or more dependencies to get it working, and that might be solvers, or that might be different math libraries, or maybe like a GUI like Qt. So that's really the problem. That's the basic problem that we're trying to solve, is get this thing installed with all of its dependencies so that people can actually use libraries without completely annoying their users.
So doesn't this end up causing other type of bloat? Like, won't every install of a high-level package pull in yet another identical install of netcdf or hdf5 or some common library?
So not necessarily. So Spack lets you essentially reuse the version of that other library that you've already installed, assuming that the package you're installing is compatible with it. So if I say, Spack install some code that requires netcdf, and that code can build with netcdf 1.3 and you already have it installed, then it'll just link against the existing version. Now you may get codes that require some other version of netcdf, which is another one of the things that Spack was created to address. And in that case, it'll just build you two versions because you need them. You have a code that's linked against 1.2. You have another code that requires 1.3. Well, you can't reuse the 1.2 version. You have to go and build a new one. But it won't disturb the existing install. So you can do both. And I think that's one of the main differences between Spack and what you might use as part of your OS, or if you install something with your OS package manager.
So we actually do a lot of things like this manually right now. We'll have software install locations that'll be like Red Hat Enterprise 6 netcdf /526 Intel 4.2 / and we end up with a million different versions. So this is a system for kind of implementing all of that and figuring that all out.
It is, and it probably does more than you might think if you're used to making directory hierarchies. So I guess if you look at the way that different sites install software, so like if you use the systems at TAC or do you mostly use the local systems at Michigan?
I use and support on both, so I'm
okay.
familiar with the way some places do things.
Yeah, so like Oak Ridge, Livermore, Texas Computing Center, I guess Michigan too. They try to make these directory hierarchies, and it usually includes things like the compiler version, the architecture, the MPI version, and so on. And that's actually that's only a subset of the dependencies of most of the things that are installed there. So essentially, if you try to build a purely hierarchical versioning scheme like that, you cannot you're not covering all the configuration parameters of the software. So where Spack is a little different is that the version or I guess the configuration of something that you install is actually the full DAG of dependencies. And the version itself is just a hash of that entire DAG that includes all of that provenance information. So this software, its version, its compiler, the compiler version, its dependencies, and all of that for them as well.
Wait, so if it's all stored in a hash, is Spack maintaining like a database someplace so I can then go ask what does this install have in terms of options for that package?
So it does. It actually, the database is pretty simple in that it's really just the install tree. And under each install, we have a little .spack directory that contains a YAML file, which is just, it's like XML, but simpler, that has all the provenance information. So it tells you what that package was linked with. And then we can go and query that. So that if you type spack find, and then you type an expression like, find me all of the versions of, HDF5 that were linked with mpage, you can do that. It'll show you all of the versions that are installed that linked with that library, and you can get more specific. You can say, show me all the versions that are installed that linked with like mpage adds greater than version 3.
All right. Now I noticed too. You said earlier that you can link against dependent libraries of different versions. So let's say I've got package 1 links against some dependent package version X, and package 2 requires that same dependent version or same dependent package, but version Y instead of version X. How do you handle it? I understand how you can do that from a build system and a link system,
yes.
But how does that work at runtime?
Right. So Spack is actually it's based on the way that we already install software at Livermore, which is actually probably less, I guess, module intensive. If are the listeners familiar with modules?
No. Well, probably some, but let's go ahead and this was
Sure.
kind of a